So good morning everyone. In today's class we are going to see about the sequential circuit. So under the sequential circuit we are going to study about the state reduction techniques. So normally before going into the explanation about the state reduction techniques, let us call upon student to recap the previous classes. Please come.
Good morning everyone, I am Naveenraj, and in the previous classes we have seen about the sequential circuit and the combinational circuit. Sequential circuit only depends on the present input and the past output, and the examples for the sequential circuits are flip-flops, D flip-flops and JK flip-flops, etc. And then combinational circuit only depends on the present input state, and it does not have a feedback, whereas the sequential circuit has the feedback. And we also saw about the state table, how to draw the state table.
So in today's class, we are going to design a sequential circuit using the state reduction technique. So first, this is the given problem. So in the given problem, this is your state diagram. So here there are 7 states: A, B, C, D, E, and F, G. So each and every state's behavior is denoted by their input and output. Okay, so the numerator we get denoted here is input for this particular state. The denominator is the output for this particular state. So for example, you just consider this state A. When you give the input 0, again the state A is going to the state A itself. That time it produces the output 0. So when input is 1, the A state will go to the B state. So output is 0. Similarly, we have to look into all these states, the behavior of input 0 and 1 as well as output. So from this given state diagram, you need to draw the state table. So for that state table, so first you have to note down present state. What are the present states in the given state diagram? So these are the present states: A, B, C, D, E, F, G. Okay. Next state. So next state you will be having 2 possibilities. When your input is X is 0, it will go to the state A again. Then when input is 1, it goes to another state B. During that time, it produces outputs 0 as well as 0. Similarly, we have to write steps for all the next states, like it's B, C, D, E, F, and G. So once the table is filled, we have to see whether any state is repeating their output as well as the next state. So from this table, you have definitely know that the state E and G, the both states will have the same output as well as same next state. For example, A, E is going for A as when the input is 0. When the input is 1, it goes for F. Similarly for G, also is going for A and F. So what I am going to do here is, you can eliminate any one state. Okay, so here I am going to eliminate the state G and I am going to consider only E state. So for that, I am going to consider C equal to G. So for that, the reduced state table here is like this. So after this reduced table, you have to look once again whether any states is repeating their output and next state. So here we can find out the state D and F is again repeating. So D is going for E and F when input is 0 and 1. Similarly, F is going for same E and F when input is 0 and 1. So I am going to reduce here this F state. So for that, I have to consider D equal to F. In the third point, I have to finalize my diagram. This is my reduced state table. This is the actual state table. So this is my reduced state table. In this reduced state table, I have only the 5 states: 1, 2, 3, 4, and 5. So from this, I can again redraw the state diagram so that the number of states can be reduced. So these state reduction methods are used in all the electronic systems like ATM machines, washing machines, traffic light controller, then elevator systems also. So here, in order to what is the purpose of reducing the states? Mainly to avoid the hardware complexity. Okay, so if you use 7 states, you need to buy 7 pins, 7 hardware, 7 wires, which definitely increases your cost. And also the machine which gets slow. When the more number of apps are installed into your mobile phone, your mobile phone will get slow. Similarly, so I am reducing the state so that my efficiency as well as hardware complexity gets reduced. So after that, what I have to do? So this is my state reduction technique. Okay, so that's all about your state reduction. So let's give a summary from Yasoda Devi.
So, good morning everyone. I am Yashoda from the Department of CSE IoT in SNS College of Engineering. Now we see the how to reduce the state reduction to the using of the state diagram. First we see the state diagram. How many present states are there? It has a 7 present state. So we fill the present state A, B, C, D. So now we see the A is the present state. We give the 0 as an input. It replace next state also is that A. So it gives the output is 0. So as a present state, we also following steps are the same steps. So next we finalize the state table. Next we go for the we see what are the present state and next state and outputs are same. Now AF and next state and output zeros and ones. So A and G's are both are same. So we want to eliminate any one state. So we state the G. So next we go for the state reductions. So we assign both states are equal. So E is equal to G we assign. So next the state reductions. So E is equal to G. So we eliminate the G element, G state. So G is replaced by the E. So next we following the same steps. So D and F are both are same state. So the next state and output both are same. So now we want to eliminate any one state. So D and F both are same. Now D is equal to F. Next we go for the final state. So now D is equal to F. We eliminate the F state. So we replace the F is equal to D. So this is the final state. So we use the application where there are ATM machine and washing machine and elevator traffic signal. So it used to for reduce the hardware and improve the cost, space and improve the efficiency.